This is lesson 2 in our series about floating point binary arithmetic. For a starter, see if you can complete these two calculations. Now, floating point binary addition and subtraction we can carry out in exactly the same way as we would do with decimal addition and subtraction. We just need to make sure that the points line up before adding or subtracting the number. So let's have a look at an example. If we're adding up two decimal numbers as shown on the screen, 0.243 times 10 to the 2 plus 0.00112 times 10 to the 4, the values are currently in standard index form. The position of the points needs to actually be moved so that the exponents before the numbers can be added. So if we think about it, 0.243 times 10 to the 2 becomes 24.3, and 0.00112 times 10 to the 4 can become 11.2. Notice how we've used the exponent to move the mantissa so we have them in our standard index form. So they can now just be easily added. 24.3 plus 11.2, so 3 plus 2 is 5, 4 plus 1 is 5, 2 plus 1 is 3, giving us 35.5. If we wanted to, we could put this back into normalized index form. So now let's think about the addition of two floating point 16-bit binary numbers, where 10 bits we know are the mantissa and 6 bits are the exponent. Now we know that because binary values are currently in floating point form, the position of the points need to move according to the exponent before we can actually add the numbers. So remember, the point is after the first digit because the first digit tells us whether it's a positive or negative. That's our sign. So first of all, we look at 0.1101 times 2 to the 3. We can put that into our without standard form, so 0.110.1, and then 0.00011 times 2 to the 4 becomes 001.1. So then we can basically add them, just like we've been adding binary numbers before. So I've basically put them in a small table here. We start, remember, on the right hand side. Notice how I've added all those zeros, I've kept them in. So 1 and 1, well there's 2 of them, so it becomes 0 carry 1. We carry the 1 over the decimal point. We then have 1 and 1, which is 0 carry 1, 1 and 1, 0 carry 1, 1 and 1, which becomes 0 carry 1, and then finally we have our 0 and our 1, which is at the end. You can see how we've kept that value in. So we've added them up and it becomes 1000.0, and we can turn that into standard form, can't we? And it's actually floating point form, or we can actually sometimes call it normalized index form. So that can be 0.1 times 2 to the power of 4. Alternatively, if we put it right back, it can be 1, 0, and then we represent our power and our exponent in binary. So here's an example. You'll see we want to add the following 16-bit binary numbers where 10 bits are the mantissa and 16 bits are the exponent. Please pause the video and try and complete this now. Okay, so first of all, we need to think about how we're going to represent them. So we know, and you can see we can represent them here, is 0.1111 times 2 to the power of 2. We can then represent that in a decimal format, 011.11. The same can be done with the second value. We then add them up in the same way. So look at how we write them above each other. We can then put it back into floating point form, and then we can put it into normalized indexed form. So here's the next example. Now you'll notice here that we've got a negative exponent, 2 to the power of minus 1. You can see actually it's not much different really, because when we write it out, we know it becomes 0.01111101. Because really what we've done is we've removed that negative 1, haven't we? And rather than moving the decimal plates to the right, we're moving the decimal point to the left. Notice how we know it's a minus 1, because when we were looking at how to represent negative exponents, the first exponent is represented by 1, 1, 1, 1, 1, 1. Remember, the first bit is the positive or the negative, and after that, remember, all ones on give minus 1. We can then basically add them in a similar way and represent them back into normalized index form and floating point form. So subtraction is going to happen in a very similar way to we used to subtracting values. We've got two floating point, so they're in floating point form, remember, 16-bit binary numbers. 10 bits the mantissa and 6 bits are the exponent. You can see the two numbers at the top in bold. Now they're currently in floating point form. So the first thing we're going to do is change them to a normalized index form. So we have to represent the exponent and the mantissa in our form. So you can see that it becomes, the first one becomes 0.1101 times 2 to the power of 3. We then convert it into our decimal form, our binary decimal form. We do exactly the same for the other bat value first. We then need to convert the second one to a negative number. Remember, we can't add negative numbers, so we can't minus numbers rather, we can only add negative numbers. So to do that, we flip the bits and add 1. So if you look at flipping the bits, it becomes 110.0 and then lots of ones. We add 1 to this. So then that becomes 110.1. Now just be careful here. Think, is the second number bigger than the first? If it is, you're going to know after the subtraction the answer will actually be a negative and in 2's complement. So in binary subtraction we ignore the overflow, remember, when we do this. So now you can see is adding those values together. Once we've added the values together, remember it's actually going to be in 2's complement form. So we now need to put it back into normalized floating point form. So in a normalized floating point binary number, remember the mantissa sign is 0 and the next digit is the number 1. So this becomes 0.101 times 2 to the power of 3, or 0101. Then we have a significant amount of zeros, and remember our exponent then becomes 000011, because that's how we So here's another example of substitution and practice for us. There are two binary numbers here, 16-bit binary numbers. Remember, the first 10 bits in the mantissa and the 6 bits the exponent. See if you can figure this one out yourself by looking at this value and then look at the answer. Have you managed to get it correct? You now have two different questions to do, two types of questions. Please try and complete these and then we'll see what the answers are. You now have two different questions to do, two types of questions. Please try and complete these and then we'll see what the answers are.